Hello and welcome to section 9.1.2. We're looking at polynomial multiplicity and roots or zeros today. So roots of a function. What is a root? The root of a function is where the graph crosses or touches the x-axis. So basically it is going to be the same thing as an x-intercept. Besides being called roots, we can also call them zeros. So they kind of have three names: roots, zeros, and x-intercepts. All mean the same thing. The only real difference is that roots or zeros, we're often going to write them as x equals, whereas x-intercepts are written always as ordered pairs. Okay, so they are the same thing, but roots and zeros are usually just rated as x equals. All right, investigating now multiplicity. So using our graphing calculator Desmos, we're going to graph this equation here. So x minus 2 quantity squared times x plus 1. And the first thing it says is name the roots or the zeros for the function. So if we look here, it looks like it's crossing through at -1 and at 2. And if we look at our table, we can clearly see that that is the case. -1, 0, 2, 0. So again, since we're just calling them as roots, we can just say x equals -1 and x equals 2. And then the next part says what happens to the graph at each of these roots. Does it cross or bounce off the x-axis? So what we can see here is that it is crossing through at -1. So I'll say at x equals -1, it's crossing, it crosses, but at x equals 2, it bounces off the x-axis. And so we're going to repeat this for a couple here and see what's happening. So for our next one, x plus 3 squared times x minus 2. And so we see our zeros are going to be at -3 and 2. And that it is bouncing at the x equals -3 and crossing at the x equals 2. Oops, sorry, bounces at -3. My bad. It's bouncing here, crossing at 2. All right, let's take a look at the next one. We're trying to find patterns ultimately. Next one, x plus 5 squared, x plus 8. So we're seeing roots at 1, 2, 3, 4, 5, and 6, 7, 8. So at x equals -8, and at x equals -5, and at the -8 it's crossing. And at x equals -5, it's bouncing. So hopefully you're starting to see maybe some patterns develop. We're kind of seeing that when you have the squared, that's when it's bouncing. And if we have a first power, it's crossing at that spot. And if you notice, the root or the zero is always the opposite of the factor you see, because you're setting each factor equal to 0 anytime you are finding that. All right, let's try the next one. See if these patterns continue. Now we have a cubed factor and a squared factor. See if that changes anything. So now it's x plus 5 So it's very similar to what we just did, but now it's cubed instead of squared. And then x plus 8 squared. And so our roots are still at -8 and -5. And it's still bouncing at the -8, and it's still crossing at the -5. But notice how it's not crossing straight through anymore. Notice how it's kind of like doing the cubic. So it looks like if I covered this up, this looks like the cubic function almost. So I like to call this the cubic shuffle because it's kind of growing, flattening out there, and growing some more. Okay, so that's changing a little bit, but it is still crossing through. So at x equals -8, it's still it is bouncing at the -8. And at x equals -5 is where it's crossing. But it's doing the cubic shuffle. All right, on to the next one. So now we have x plus 1 quantity squared times x minus 4, whoops, to the third. So it is touching at -1, and we can double check that by looking. -1 is at 0. And again, so x equals -1, and it looks like 1, 2, 3, 4. We can double check that. 4, 0, yep. And again, it's going to be bouncing at the -1. And at the x equals 4, it is crossing. But again, it is flattening out a little bit. It's not crossing straight through, so we're going to be doing that cubic shuffle. All right, now let's take a look. The next one, we have x plus 1 to the 4th times x minus 3. So this is the first time we have something greater than a 2 that's an even. So let's see what is happening. So it is still going to be bouncing. It's just going to be a different kind of shape. So it is still bouncing. That's all that matters. And then it's crossing straight through at the 3. So our roots, our zeros, are still going to be -1 and 3. And it is bouncing at -1. And at 3, it crosses. All right, so hopefully we're kind of finding a little pattern here. You should always kind of see the roots are the opposite of what you see in the parentheses. Again, that's because if we use the zero product property and actually solve for the factors, you always get the opposite of what you see inside those factors. When we see a even exponent, all the even exponents were bouncing. All right, the -3 bouncing, the -5 bouncing, the -8 bouncing. And anytime you had a 1 or a 3, it was crossing, but just remember for the cube, it also did that cubic shuffle there. So right here it says predict the x-intercepts for the graphs of the following. Do you think the graphs will cross or bounce at each of the zeros? Explain, then check your answers on your calculator. So take some time, please, and answer these on your own. All right, so for this one, you should have roots at -2 and at 3. Again, if I set each of those factors equal to 0, I'd get -2 and then +3. For the x equals -2, we have an even exponent, so that would bounce. And then at x equals 3, we have a 1, which is odd, so it's going to cross, and it's going to cross straight through. For number 4, our roots are going to be -1 and 2. Here we have an even exponent of 4, and remember, anytime you have an even exponent, it's just going to bounce. And then at 2, the x minus 2 factor is being cubed, so it's going to cross, but it's going to do that cubic shuffle. And then for the last one, we would have x equals -3 and x equals 2. This one would cross, and the 2 would bounce. All right, so it actually might help if we go to the bottom of page 5 here now. It says you've just investigated a concept called multiplicity. So those crossing or bouncings are called multiplicities. Anytime you have an odd multiplicities were like the 1 and the 3, those always crossed. Okay, so those are going to cross the x-axis. Remember, though, if you have like a cube, it's going to do the cubic. Okay, so anything higher than 1, like a exponent of 3 or 5, 7, will do the cubic. But still going to cross through. And then even multiplicities mean that the graph will bounce off the x-axis. So, exponent of 2, 4, 6, 8, those are all bouncing. And for the most part, they're all going to look the same. They're not going to be much different, whereas like the odd will cross straight through or do the cubic. All right, so now that we kind of looked at that, it says now we're going to be given some graphs. It says for each of the following, write a possible function for the graph. Check your answer on your graphing calculator. So if we look here, we always want to look for our roots first. So we have a root at -4. So remember, that would be a factor of x plus 4. And then we have a root at 1, which would be a factor of x minus 1. So at the root of -4, it is crossing straight through there. So that means our exponent must be odd, and that it's straight through, it's just going to be a 1. So you can put a 1 there if you want, or not put anything there. And then this one is bouncing off at +1, so that means the factor of x minus 1 must be squared. For number 2, we have roots at -2 and 1. So our factors would be x plus 2 and then x minus 1. It is bouncing off at the -2, so our factor of x plus 2 must be squared. And then notice how this one is definitely flattening out. It does look like a cubic right there. So that means the factor of x minus 1 must be cubed. Alrighty, and try this last one on your own. For letter C, we're going to have roots at -2 and 2, so our factors would be x plus 2 and x minus 2, and they are bouncing at both of them, which means both would need to be squared. And then last thing we're going to look at is to summarize what you learned about the roots or zeros of a polynomial function and what happens at those roots or zeros. So again, take a second and fill that out. So main things you want to make sure you write down are roots are when you set each factor equal to 0. and solve. Okay, normally they're going to be what the opposite of what the opposite of what you see. And then we can talk about our multiplicities. Odd multiplicities. Cross the x-axis. And even multiplicities bounce off the x-axis. All right, so there is our information. We're learning a lot more about polynomials each and every day.